Today we're doing section 3.4, day 4, so this is our last day in section 3.4, and we're going to be doing the dreaded word problems, but I hope you feel that they aren't too bad after we do them. So our first problem says medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. The risk is modeled by R equals 6e raised to the 12.77x, where x is the blood alcohol concentration and R is given as a percent, is the risk of having a car accident. What blood alcohol concentration corresponds to a 17% risk of a car accident? How is this shown in the graph? So they give you the equation and they give you the percentage, so we simply just plug in the percent for the R. Notice the problem says it's measured as a percent, and that's why we don't change it to a decimal. We need to get our base by itself, so we're going to divide both sides by 6. Because this is a word problem, I want my answers to be the most exact as possible, so I am not going to write 17 over 6 as a decimal. I'm going to leave it as a fraction. So from here, I have an exponential equation. In order to solve it, I need to put it in log form. So I'm going to use natural log e of 17 over 6 equals 12.77x. Again, calculators are in base E, so you just type natural log of 17 over 6, and we get the decimal 1.0415. I would say let's try and use 4 decimal places when we are doing word problems. We'll divide both sides by the 12.77. And we get x equals 0.082 is their blood alcohol content. So for our next example, it says people with lower incomes are more likely to report that their health is fair or poor. The function f of x equals models the percentage of Americans reporting fair or poor health, f of x in terms of annual income, x in thousands of dollars. According to the model, what annual income corresponds to 10% reporting fair or poor health? Round to the nearest $1,000. So again, we're going to plug our 10 in. So again, it says percentage, so we leave it. So I have 10 equals 54.8 minus 12.3 ln of x. You cannot subtract these two numbers, the 54 and the 12, because the 12 is attached to the natural log. But I can subtract the 54.8 over to the 10. When I do that, I get negative 44.8 equals a negative 12.3 ln x. We're going to divide both sides by this negative 12.3. When I do that, I get 3.642. And I'm in log form. My only option is to do the opposite, which is putting it in exponential form. So remember I have an e here. So this is e to the 3.642 equals x. Use your calculator, you raise e to the 3.642, and you get x equals 38.17. The directions say to round to the nearest thousand, so we would say this is $38,000. Okay, again, fairly easy word problems. They give you the word problem, you just have to plug the number into the correct spot. Lastly, letter C, it says how long will it take $25,000 to grow to $500,000 and 9% interest compounded monthly? So we did these type of word problems at the beginning of the chapter. Just now the unknown is going to be a little bit different. So now the time is unknown. So A is our 500,000. Our principal or our starting amount is 25,000. I have 1 plus. Our interest rate is 0.09. Compounded monthly is over 12. Raised to the 12t. So we're going to kind of do this problem in stages. I'm going to divide this 25,000 over. And you know that all those zeros are there. When I do that, I get 20. And this part here, you would type in the calculator, so you would only type the 1 plus 0.09 divided by 12, not raising it to the 12th power. So just the part that's in the parentheses. Again, 4 decimals, so I have 1.0075 raised to the 12t. So I'm in exponential form, so naturally I need to do the opposite, which is putting it in log form. So I have log, the 1.0075 is the base, so that goes there, of 20, and it's equal to 12t. Remember, for the left side, we do the change of base, so you would type log 20 divided by log 1.0075. When you do that, you get 400.927 equals 12t. And we're going to divide both sides by 12. And I get t equals approximately 33 years. So you can just round to a whole number for problems when we're talking about years. All right, that's all for today. We'll do some practice tomorrow.